Hello students, in this video we are going to discuss numerical problem number 9 from chapter of torque on a current loop and moving coil galvanometer from Nootan Physics book. Students, before going through the solution of this particular problem, I would recommend you to first go and watch the solution of the same chapter, question number 8. You will find the link of the same by clicking on the top right hand corner of this particular video. Students, in that video I have already discussed what do we mean by current sensitivity and voltage sensitivity. So that video will give you an insight towards these two terms. Here let me just start directly by solving this problem, and let me just give you a brief intro. What do we mean by a current sensitivity and voltage sensitivity? Current sensitivity SI is defined as deflection produced per unit amount of current flowing through the galvanometer or the ammeter, and this is equal to NAB upon C, where N happens to be the number of turns of the coil making the galvanometer, A being the area of the coil, B the magnetic field in which the coil is suspended, and C is the torsional constant of the suspension wire. Similarly, the voltage sensitivity is defined as the deflection produced per unit potential difference applied across the ends of the galvanometer or the voltmeter, and this can be rewritten as phi upon V can be written as IR, so V I times R. So you can see this phi upon I is nothing but the current sensitivity. The SV is equals to SI upon R is equals to NAB upon C times R. So these two expressions are quite useful in solving numerical problem number 8th and 9th. So please take care about both these expressions, and I would once again remind you to go and watch the solution of numerical problem number 8 from this particular chapter only. Now here the question says, to increase the current sensitivity of moving coil galvanometer by 50%, its resistance has been increased so that the new resistance becomes twice of the initial resistance. So by what factor does its voltage sensitivity changes? So students, it's basically relating the voltage sensitivity with the current sensitivity of the galvanometer. So let's try to solve up this particular numerical problem. Let me assume that the current sensitivity of this galvanometer is increased by a factor of 50%. Okay, so let's assume that the initial current sensitivity was X. Therefore initial voltage sensitivity of the galvanometer will be SI upon R. This is the relationship between these two quantities. You can see over here I have mentioned them. So SI, that is the current sensitivity, is X and initial resistance was R. So this becomes my relationship between voltage sensitivity and current sensitivity of the galvanometer. Let me mark this as equation number 1. Now what the numerical says further, it says that to increase the current sensitivity of this galvanometer by 50%. So what is the initial current sensitivity? That is X. So in order to increase it by 50%, okay, so what I have to increase the current sensitivity of this galvanometer by 50%. So the new current sensitivity will be 1.5 times of X. So this becomes my new current sensitivity. What I have to do? I have to now increase the resistance of the galvanometer to double the initial value. So now my new voltage sensitivity will be SI dash upon R dash. That is the relationship between the current sensitivity and the voltage sensitivity. Therefore the new voltage sensitivity is now 1.5 times of the original current sensitivity upon the new resistance is double to that of the initial resistance. So this becomes my new voltage sensitivity of the galvanometer, and let me write down this as an equation number 2. Now I need to compare the voltage sensitivity original to the new one. So dividing both the equation, once I divide both of them, SV upon SV dash, so that will be SV is what? X upon R. And what is SV dash? That is 1.5x upon 2R. This R and this R cancels out. This X and this X cancels out. So I will have 2 upon 1.5. Solving it out, 5 4s are 20 and 5 3s are 15. Therefore, SV upon SV dash is equals to 4 by 3, or SV dash is equals to 3 by 4 times of SV, or simply new voltage sensitivity is 0.75 times the original voltage sensitivity, or one can say the new voltage sensitivity is 25% less than the original voltage sensitivity. You can state in both the manner. Here the questions, the answer says the voltage sensitivity is reduced to 0.75 of its original value or the previous value, which you can see directly from this particular expression. You get the same meaning. Or also what you can say that the new voltage sensitivity is reduced by 25% of the initial value. So all these ways of stating the voltage sensitivity. I hope this solution will help you to solve and to understand how to solve these numerical problems. Friends, if you find my videos helpful for you to understand and solve numerical physics, please kindly share, subscribe, and pass on these videos with your friends and classmates. Thank you very much.